after a short break. I think on June 27th started this 11th standard, 12th standard, or second PUC, P block elements. On June 27th started. Due to some technical problem or there is a short break 1 week. After 1 week, again started this topic in second PUC, 12th standard P block elements. On 27th of June, just introduction about P block elements. Both first and second year are repeated, revised, and explained. Then some important points about 15th group explained to you, introduction given. Then some important points about 15th group elements like nitrogen, phosphorus, arsenic, antimony, and bismuth. Now, again I will repeat some important points. Just I'll introduce, again I will repeat about 15th group elements, and I'll continue the further concepts. Okay? In P block elements, total 6 groups are there: 13, 14, 15, 16, 17, and 18 groups. In first year, 13 and 14 groups completed, boron family and carbon family. Now in 12th standard, that is in second PUC, four important P blocks remaining, that is 15, 16, 17, and 18 groups. Now are the 15th group elements. Nitrogen, phosphorus, arsenic, antimony, and bismuth are collectively called 15th group or nitrogen family. These 15th group elements are called nicogens. Why these are called nicogens? Because such a compounds or molecule creates a suffocation, and their compounds are called niconoids. Nitrogen compounds, phosphorus, arsenic, antimony, and bismuth compounds. And here the availability or the occurrence of nitrogen, phosphorus, arsenic, antimony, and bismuth clearly given in last class. Nitrogen generally gaseous state diatomic molecule, 78% by its volume and 80% by its mass available in atmospheric air and earth crust. Nitrogen earth crust exists as their nitrates: potassium nitrate, sodium nitrate. Indian saltpeter and chili saltpeter, 2 examples given. And nitrogen also mainly present in proteins, alpha amino acids. Amino acids, 20 amino acids are there in that nitrogen based alpha amino acids mainly present in the amino acids, that is proteins. Next here the phosphorus. Here phosphorus mainly as a mineral or the phosphorite rock. Some apatite families are there: chloro, fluoro, hydroxy apatites, and phosphate rock Ca3PO4 taken twice, that is Thomas slag given here. And here phosphoproteins, proteins, milk and egg also, in the milk and egg also present phosphorus, mainly in plants and animals present this phosphorus under the name of phosphoproteins. Then here arsenic, antimony, and bismuth are generally exist in earth crust as their sulfides. Arsenious sulfide, stibnite sulfide, and bismuth sulfide as their sulfide ores are available in earth crust, that is occurrence. And their general electronic configuration also given in last class. Rare gas NS2 and NP3. For all P block elements, general electronic configuration also given: NS2 NP6, 1 to 6. Then based on their electronic configuration, one most important point explained to you, that is anomalous properties of nitrogen, peculiar properties of nitrogen. Once we can observe the electronic configuration, that is EC of these 15th group elements. General one is rare gas NS2 and NP3 is the general electronic configuration. In its outermost orbit, 5 valence electrons are there. Here, 2 are paired and remaining here, 3 are unpaired. It is 15th group element. Once we can observe, here the 16th group elements general electronic configuration, 16th group, that is rare gas NS2 and NP4 it is. In its outermost orbit, 6 valency electrons are there, like 6 valency electrons. Out of the 6, are the 2 pairs, 2 unpairs are there. For example, once we can observe here 14th group elements general electronic configuration, that is NS2 and NP2. In its outermost orbit, here are 2 electrons paired and 2 are the unpaired. But in first excited state, maybe here NS1 and NP3, like 4 unpaired electrons are present, that is tetravalency of these 14th group elements. Now 14, 15 and 16th group elements means your carbon, nitrogen and oxygen family. So generally your left to right size, what happens? Decreases size. Top to bottom size increases. Generally relation size decreases, ionization energy increases. Now your electronegativity also increases. So among these, which is more stable and ionization energy is more compared to nitrogen and oxygen means, according to the general concept, your left to right size decreases, ionization energy increases. Oxygen ionization energy is more than compared to the nitrogen, than compared to the carbon generally. But in this case, here the ionization energy of nitrogen is greater than ionization energy of oxygen. Why? Generally, this is the first year concept, the periodic table ionization energy, first year concept. Why the ionization energy of nitrogen is greater than compared to the oxygen, even though in periodic table left to right size increases, size decreases, electronegativity increases, ionization energy also increases. According to that concept, oxygen ionization energy is more than compared to the nitrogen. But in this case, it is not like. Why? The ionization energy of nitrogen is more than compared to the oxygen. For that purpose, written this is a 15th group, 16th group and 14th group elements. Once we can observe the general electronic configuration in 15th group elements, nitrogen family, here it is completely paired and it is off filled. It is completely filled and it is off filled. According to Hunds or the Heinz rule, off-filled or completely filled orbitals are more stable. You get the extra stability. And it is more stable because it is completely filled, it is off-filled. That's why it is more stable. More stable means somewhat difficult to remove the electron from its outermost orbit. That's why your 15th group elements ionization energy is more than compared to the 16th group, even though size of nitrogen is more than compared to the oxygen. Clear point? So in examination, they'll give like increasing, decreasing order of ionization energy. Generally, your boron, carbon, nitrogen, oxygen, fluorine, like. increasing, decreasing order of these. So generally boron, carbon, nitrogen, oxygen energies, ionization energy generally increases. Generally they'll show like this, order is like this. But this is wrong. Because size, okay, decrease, ionization energy increase, but whereas in this case based on their extra stability of filled or completely filled orbitals, the ionization energy of nitrogen is more than compared to the oxygen. That's why we can write boron, carbon, oxygen, then nitrogen, then fluorine. This is the correct option based on their sizes and ionization energy based on their off field. That's why don't underestimate general electronic configuration and electronic configuration of each and every one element present in that long form of the periodic table. First, better you read introduction. While reading the introduction, better you concentrate on electronic configuration. Each and every one element electronic configuration important. And identify what are the important things, what are the points, main important points present in its outermost orbits. Now the difference, variation between 14, 15 and 16 clear. Like questions they'll create in objective. Okay, anyhow, now here main important thing is about only 15th group elements, general electronic configuration. Only 15th group elements, general electronic configuration. Once we can observe nitrogen, already explained to you. Again, just one word repetition. Once we can observe nitrogen, its atomic number is 7, electronic configuration is 1s2, 2s2 and 2p3. This is. It is the outermost orbit of nitrogen. Here 2s2 and here 2p3. Here 2 electrons and here 1, here 1 and here 1. But here in nitrogen there is no 2d orbital. Unavailability of d orbitals. Whereas in case of phosphorus 15, now here the 1s2, 2s2 and 2p6, here 3s2 and 3p3. Now here valence electrons here also 5 in phosphorus. Wherever or whenever required for the phosphorus, here the d orbital is ready to accept. Availability of this 3d orbital. Now, whenever or wherever required to expand, your electrons are excited from 3s to 2a 3d orbitals. That's why here, except nitrogen, remaining 15th group elements, phosphorus onwards, availability of d orbital is present. Availability is there. That's why here the electrons are excited from 3s2 to 3d. First excited state like 3s1, 3p3 and 3d1. Now here valence electrons are 5 only, there is no change. But here unpaired electrons are here 5 are there. That's why I'll use the word, that's why here for nitrogen maximum covalency is equals to 4 only. Covalency means combining capacity. With this, with this, with this, with this. Only these 4 are only participate in a chemical reaction. That's why for nitrogen maximum covalency is 4. That is due to the unavailability of d orbital. Cannot excite. First excitation cannot take place. Only these valence electrons, one is paired. Remaining 3 are the unpaired electrons only involved. That's why covalency is 4. But here I'll explain that. But here the maximum oxidation state is +5 for nitrogen. Whereas in case of phosphorus and other elements, maximum covalency is 5 because here 1, 2, 3, 4, 5 all these valence electrons are involved. That's why for this here the maximum covalency is equals to 5 and oxidation state also exhibit maximum +5. Oxidation state should not exceed should not exceed their valence electrons. For example, for nitrogen family, maximum oxidation state in examination, if they'll give, shows +6 is nothing but that is wrong, because in its outermost orbit, maximum how many valence electrons are there? 5. That's why maximum oxidation state always for all these elements maximum +5. That is a very, very important concept. So based on this electronic configuration, nitrogen, phosphorus, arsenic, antimony, bismuth, already in last previous class explained to you. By using all this, here nitrogen shows some anomalous properties, peculiar properties. Why are they nitrogen shows anomalous peculiar properties with the same family members like phosphorus, arsenic, antimony, bismuth? Because of unavailability of d orbital. First one, due to its small size. When size is small, electronegativity is more. More electronegativity means small in size, more electronegativity and unavailability of d orbitals, d subshell. I'll explain that anomalous properties. This is just introduction in previous class explained up to here. Then I'll start after electronic configuration and general introduction and occurrence of 15th group elements. I'll explain very clearly, slowly. If you want, better you take running notes. Are the physical properties of 15th group elements. Physical properties of 15th group elements. Physical and general combined, I'll explain. Physical and general properties. First one is physical state. Physical state of 15th group elements. Are the nitrogen, phosphorus, arsenic, antimony, and bismuth. Physical state. Now, nitrogen is a gas at a room temperature. It is a solid, but easily evaporates, easily vaporizes. Solid, but at room temperature easily vaporizes. Arsenic, antimony, and bismuth are the pure solids at a room temperature. Clear. Physical state is clear. Then here, second thing is your atomic radius. In that atomic radius, we can use covalent radius. Covalent radius and your ionic radius. So generally, your atomic radius, somehow difficult to calculate the atomic radius of each and every one element because atom is too small compared to molecule. That's why in covalent or in metallic or in van der Waals radius, depending upon the type of element, we can calculate the covalent radius which are bonded by a covalent bond. This covalent radius generally, once we can observe here the nitrogen, phosphorus, arsenic, antimony and bismuth, your N is equals to energy level here 2, here 3, here 4, here 5 and 6. Top to bottom energy level increases. While writing the electronic configuration, we'll get it, this energy level. Top to bottom energy level increase means newly added electron enters into a new main energy level. That's why here the top to bottom, its size generally increases. Size increases. Because from nucleus to the outermost orbit, which are bonded by a covalently bonded by two atoms, that is a covalent radius. In first year, we know half of the internuclear distance between two atoms, same or different atoms, which are bonded by a covalent force. Like this is covalent radius means like this. This is the atom atomic radius. This is the another atom atomic radius. Here to here distance is called a internuclear distance. Half of the internuclear distance, this is called a CR, covalent radius. This is also a covalent radius. This is a complete, it is the diameter or the internuclear distance. Now, of the internuclear distance, covalent radius top to bottom increase because a newly added electron enters into a new main energy level, size increases. That's why your top to bottom covalent radius increases, left to right decreases. Generally, here we are using about groups. That's why its covalent radius is nitrogen is less than phosphorus, here arsenic and antimony, bismuth. This is the covalent radius. Covalent radius increase. But whereas in case of ionic radius, there is a slight variation. That is N is less than phosphorus, is less than arsenic, is greater, slight variation due to their inert pair effect and some important internal electronic repulsive forces. It slightly changes like this. This is now very, very important. This is the CR, covalent radius. This is the IR, ionic radius. Slight variation observed here because in objective they'll ask such a simple, which of the following statement order, increasing, decreasing order is correct? After this covalent radius and ionic radius, next thing is here, third one is IE, ionization energy and ionization potential. Both are same, already in previous class explained to you, just revision. Energy means in kilocalories, potential means electron volts. That is the difference. So, the minimum amount of energy required to remove electron from its outermost orbit. Now here nitrogen to bismuth size, what happens? Size increases, ionization energy decreases. That's why your ionization energy is inversely proportional to the size of that atom or ion. When ionization energy increase, size decrease. That's why your ionization energy is more for nitrogen than phosphorus, than arsenic, than antimony and bismuth. This is ionization energy. So ionization energy is more for this. When our ionization energy is more, size is less. Based on that atomic or the ionic size or covalent radius. Then after this ionization energy and ionization potential, electronegativity. We know electronegativity, it is the property of an element present in a molecule which has the capacity to attract the shared pair of electrons towards itself. Whenever here electronegativity character, this electronegativity character generally depends on size. Here the electronegativity is more when size, same here inversely proportional. Size is more, electronegativity is less. That's where the electronegativity order is nitrogen is more electronegative than phosphorus, than arsenic, antimony and bismuth. This is here electronegativity and ionization potential or ionization energy. Whenever electronegativity is more, that is directly proportional to the non-metallic character. Very, very important. Non-metallic character. Here ionization energy is directly proportional to the metallic character. Two are very, very important. Metallic and non-metallic character. So by using this ionization energy and electronegativity, here this is the non-metal and also a non-metal. These two are the metalloids and it is a pure typical metal based on that non-metallic character, because electronegativity is more, non-metallic character is more. Okay. So the ionization energy, generally your ionization energy is more. Sorry, Emma, 1 minute. Your ionization energy is more, that is inversely proportional to the chain is inversely proportional to the metallic character. This is ionization energy is more for nitrogen, but it is not metal. Metallic character is less. Change this. So the ionization energy is inversely proportional to size and inversely proportional to the metallic character. Whereas in this case, electronegativity directly proportional to the your non-metallic character and inversely proportional to the size of that. So based on this metallic and non-metallic characters, based on this explanation, your metallic and non-metallic characters of metallic and non-metallic characters of 15th group elements. Yeah, the nitrogen and phosphorus are the non-metals. Yeah, arsenic and antimony are metalloids. And here the bismuth is are the pure typical metallities. Okay, metallic and non-metallic characters. Then after this, after metallic and non-metallic characters, your molecular state of your 15th group elements. Your nitrogen exists as a diatomic molecule. Diatomic gaseous molecule it is. Diatomic gas molecule between nitrogen there exists a triple bond. Like among this triple bond, one is sigma bond, remaining two are the pi bonds. In previous last class explained about one p-pi bond, and one student asked about what is p-pi and d-pi. Now I will explain p-pi and d-pi bonds. Now here the two pi bonds are p-pi and p-pi bond. Here also this is the p-pi and p-pi. Nitrogen molecule do not form. Here the do not form here the p-pi and d-pi bond. Why here the p-pi and d-pi bond is not formed by this nitrogen molecule? What is the reason? Absence of d orbital in its outermost orbit of nitrogen. Why are the nitrogen do not form p-pi and d-pi, only forms two pi bonds are with the p orbitals only, not with the d orbital, because here absence of d orbital it is. That's why nitrogen forms only p-pi and d-pi bonds. Remaining elements like in molecular state, remaining elements of 15th group elements do not exist as remaining elements like P2, AS2 and SB2 or the BI2 do not exist. Why here do not exist as P2, AS2, SB2, BI2? Nitrogen exists. Why not this P2, AS2, SB2, BI2? Because of small size and unavailability of d orbital in nitrogen, it readily forms a diatomic triple bond, p-pi bonds. But here availability of d orbital, electrons are excited, and there are singly covalent bonds are available. 5 singly covalent bonds exist as P4S4SB4 molecule available. This is available like, But here the bismuth exists as a metallic form, metallic solid form, not like a molecular. This is a metallic solid form exists. So that is molecular state of 15th group elements. So after a molecular state of 15th group elements, here next important point is boiling point, melting point, and density of these 15th group elements. We know boiling point is the temperature at which above certain point that substance ready to evaporize. This is generally used for liquids and gaseous molecule. Solid is for solids we can use melting point. So the BP boiling point of this 15th group elements, generally nitrogen is less than, phosphorus is less than, arsenic is less than, Sb is less than Bi. Now your BP increase with increasing atomic mass as well as size. Melting point also increases, like nitrogen less than, phosphorus less than As, but a slight variation is greater than, As is greater than Sb, again is less than Bi. This is the very important in melting points. Due to their internal structure of arsenic, molecular structure, its melting point is more than compared to the other elements. It is just like order is ionic radius order, same as ionic radius order. Now here the density, we know the density D, generally this is the mass by volume density, mass by volume. So are they in 15th group elements, top to bottom atomic number increases, side by side size volume increase, mass also increases, proportionately density also increases. That's why the nitrogen is less than, phosphorus is less than arsenic, antimony and bismuth. This is the order of density of the 15th group elements. Boiling point, melting point, and density of the 15th group elements. This one of the most important order for objective, very important. For competitive examination, like orders are very important. The next one is based on their metallic and non-metallic characters, conductivity of 15th group elements. Conductivity. So the conductivity of 15th group elements are generally the nitrogen, phosphorus are non-conductors. Non-conductors of heat and electricity. We know the conductivity means the capacity of that element or the material ready to conduct electricity due to the presence of free mobile electrons or free mobile ions. For solids, the free mobile electrons required. For liquids, the free mobile ions required. Free mobile ions. Ions and electrons are responsible to conduct the electricity. So at a particular temperature, nitrogen, phosphorus, these are generally non-metallic substances. So are they non-metallic substances? They are non-conductors of heat and electricity. Now here the As and Sb, these two are the metalloids. These two are metalloids. These are generally poor conductors. Poor conductors of heat and electricity. Heat and electricity of the particular material. Then last one is bismuth is a good conductors of heat and electricity, that is due to the presence of free mobile ion in its metallic structure. Now here the Bi is a good conductor. Good conductors of heat and electricity. So these are the some important points about conductivity of 15th group elements. Then one of the most important point is about allotropic forms of 15th group elements and catenation property. These are the remaining two important points present under general and physical properties of 15th group elements. Here next important point is allotropy. Allotropic forms. Allotropic forms of 15th group elements. Here except Bi bismuth. Except bismuth. Remaining all elements show or exhibit allotropic property. Here nitrogen shows two important points. They are alpha form, alpha nitrogen form, that is at a low temperature exists as a cubic crystalline form. Cubic crystalline form. And here second one is beta form, that is hexagonal crystalline form, crystalline solids. At one particular temperature, nitrogen exists into two allotropic forms. So what is allotropic form of any atom of an element? Means one atom of an element exists into more than one or the two or more different physical forms. See here, the nitrogen in low temperature in solid state, alpha form is nothing but cubic structure. Beta means hexagonal crystalline structure. Two important forms. But atom of an element is same nitrogen only. That is allotropic form. Yeah, allotropic form of an element, generally atom of an element or any substance exists into more than different forms. Composition is same, nitrogen. Next here phosphorus. Except bismuth, remaining all are exhibit nitrogen given, remaining here phosphorus. Here phosphorus generally shows here the white phosphorus. White or also we can use slightly pale yellow phosphorus. Here the red phosphorus. Here the scarlet phosphorus. Here the violet phosphorus. And here the black phosphorus. These are the some important allotropic forms of phosphorus. Yeah, very important concept, allotropic forms. In this unit only, while explaining some important compounds of phosphorus, again I will repeat the types and how to convert alpha and beta forms of phosphoruses. White and red phosphorus are very important. This. Then here arsenic, here gray arsenic. And here the white or the yellow, this is white or yellow form, like black arsenic form. Now here the SB, generally it is metallic form exists. Metallic and explosive form of SB, and also it exists as some yellow color, that is white or the yellow color. These are the some important allotropic forms of 15th group elements. Here the bismuth do not exhibit any allotropic forms because of its metallic nature, metallic bond strength, do not form any other important allotropic forms. Next. Last one is in physical and general properties of 15th group elements. Last one is catenation property. What is catenation property? In 14th group elements, first year clearly explained. Among all known elements, The highest catenation property element is carbon. Catenation is nothing but a self-linkage. Catenation property, that is a self-linkage property. Yeah, the self-linkage property, mainly this catenation property depends on bond energy. So the bond energy is directly proportional to the catenation property. Bond strength is small, catenation property is small. Yeah, due to the carbon-carbon good bond strength and self-linkage is more, themselves combines to form like carbon-carbon-carbon like. Yeah, innumerable carbon compounds are formed due to its tetravalency and catenation property. To form a long chains and rings, carbon has the highest catenation property among all known elements. Themselves carbon-carbon like combines to form a long chains or the rings or any cyclic forms. Similarly, yeah, 15th group elements also not like carbon, its catenation property generally depends on bond dissociation, bond energy. That's where the nitrogen catenation property is more than compared to phosphorus, than compared to arsenic, than Sp, than Bi. This is because between nitrogen triple bond strength is more than compared to the phosphorus. Very important concept here. So catenation property is directly proportional to bond energy. Nitrogen triple bond energy is more. That's why catenation property is more. Clear? Based on this bond energies, yeah, one of the most important, we can expect one question PUC based on their bond energies. Here there exists a nitrogen and nitrogen between, there exists a triple bond like this. Whereas in case of phosphorus like P and P, like tetrahedrally white phosphorus like this is the phosphorus and phosphorus, tetrahedrally bonded like this. Now here the total number of sigma bonds in P4 molecule, here the white phosphorus sigma, here the sigma bond, and here the sigma and sigma. 1, 2, 3, 4, 5 bonds are present. 5 sigma single bonds are present. So to break a bond between phosphorus and phosphorus single bonds are there. Yeah, the single covalent, a single sigma bond is present. Whereas in case of a nitrogen and nitrogen, there exists a triple bond. Due to the presence of this triple bond dissociation energy is more than compared to the phosphorus and phosphorus. So to break a bond between phosphorus and phosphorus, less amount of energy required because only one bond is present, whereas here sigma, pi, 3 bonds are present. So due to the presence of nitrogen triple bond dissociation energy is more to break a bond, triple bond, than compared to the phosphorus and phosphorus. Yeah, important thing is, note point is here, that is nitrogen single bond energy is less than phosphorus and phosphorus single bond. Why? Very important. So generally nitrogen triple bond energy is more than compared to the phosphorus single bonds, but it is here reverse. So the bond energy of nitrogen single bond energy is less than phosphorus and phosphorus single bond energy. Why? Give reason. Very important 2 marks question. Because a reason is here, between nitrogen single bonds are present due to the presence of small size and presence of lone pairs. Yeah, the lone pairs. Yeah, because of its small size, yeah, between lone pairs, and here also electrons inter-electronic repulsion takes place. Inter-electronic repulsions are available due to the presence of inter-electronic repulsive forces. Nitrogen single bonds are easy to break up than compared to the past-present single bonds. In a NCERT book, very clearly given in one paragraph, just read this paragraph, very important. Bond dissociation energy of a triple bond is more than compared to the single bonds of phosphorus, whereas bond energies of a nitrogen single bond is less than the past-present single bond. Very important question this is. So all these physical and general properties of 15th group elements, better you read from NCERT book. Given in our textbook one table, in that table all characteristics covered, and with the help of some values, don't by heart all values, just observe it, how it increases or the decreases. Very important concept. Based on this, maybe they'll ask one objective or maybe one more question in theory or in objective level. Then after physical properties, now I'll start some important chemical properties. Chemical properties of 15th group elements. And this chemical properties of 15th group elements, main important thing is here variable oxidation states. Variable oxidation state or oxidation number. We know in first year oxidation state and valency. So the oxidation state and valency, we know clear difference between these two. Now here the oxidation state of an element is the apparent charge possessed by that element. Valency is the combining capacity of that particular element. Number of bonds formed by valency or the covalency or electrovalency in chemical bonding and oxidation state explained. Now here the 15th group elements are nitrogen, phosphorus, arsenic, antimony and bismuth. These are 5 elements. Here are the common oxidation states. So the common oxidation states are -3 + 3 + 5. These are the common oxidation states. So why not sir +6? Why not sir +7? Now here the +6 and +7 are not possible. Why? Because in 15th group elements maximum valence electrons are how many? 5 only. That's why maximum shows +5 oxidation states. So common for all these elements, common either may be -3 or +3 and +5 oxidation state. Particularly for nitrogen shows +1, +2, +3, +4, +5 in its oxides. I'll explain very clearly about this. Oxides of nitrogen, all the 5 oxidation states are present. Here also exhibit here the -3 oxidation state in one molecule, that is NH3 ammonia. See here, nitrogen we don't know. Let us consider here the X. This is X plus hydrogen is +1 into 3 is equals to 0. Here X plus 3 equal to 0. X is equals to -3. Now in ammonia, nitrogen shows -3. And here minus 3 also shows in N3H. This is ammonia. This is called a hydrozoic acid. This hydrozoic acid is a monobasic acid. Monobasic acid it is, hydrozoic acid. Now once we can observe this monobasic acid, hydrozoic acid, nitrogen we don't know, that's why here the 3 into x plus 1, hydrogen is equals to 0. Now here the 3x is equals to minus 1, x is equals to minus 1 by 3 oxidation state. That's why, yeah, nitrogen shows here plus 1 to plus 5, minus 3, minus 3 also, minus 3 and minus 1 by 3 also exhibit. Now, here nitrogen generally shows a disproportionation reaction also. What is a disproportionation reaction? In a molecule or in a species, one atom of an element shows both oxidation as well as reduction. Such reactions are called disproportionation reactions. Yeah, the nitrogen exhibit disproportionation property, that is converted into plus 1 to plus 4 only, disproportionate, not plus 5. See, I'll take 3 moles of HNO2. This is the nitrous acid. On heating, it becomes here the HNO3, nitric acid, plus here the NO, 2 moles of NO, nitric oxide, and here the water molecule is formed. Here 3 and here 3 balanced reaction. See here, 3 nitrogen atoms are there here. Here 1 and here 2 balanced. Hydrogens 3 are there, 1 and here 2 balanced. Oxygen atoms 6 are there, 3, 2, 5 plus 1 balanced. Once we can observe here oxidation state is plus 3 oxidation state. Now once we can observe here oxidation state is plus 5 oxidation state. Here oxygen is minus 2, composite is plus 2 oxidation state. See here, once we can observe this oxidation state of this nitrogen in nitrous acid, this is nitrous OUS, lower oxidation state. This is the higher oxidation state, nitric oxide. Now here the plus 3 to plus 5 oxidation state. What happens? Positive charge, what happens? Increasing. Positive charge increases means your removal of electron takes place or gaining of electrons takes place. Removal of electrons. Removal of electron is nothing but, here it is oxidation or the reduction. Loss of electron is called a oxidation, it is. So nitrous acid to a nitric acid oxidation reaction takes place because positive charge rises, removal of electron. After removing electron, plus 3, plus 4, plus 5 increased. After gaining, plus here same nitrogen here to here, once we can observe here, plus 3 to plus 2, positive charge decrease. Here removal of electrons, but here gaining of electrons, that is reduction reaction. Reduction. See here, this nitrous acid can disproportionate. Disproportionate means it can undergo both oxidation as well as reduction. Redox reactions are different, disproportionation reactions are different. So here redox reaction is nothing but, for example, here Na plus gaseous reaction plus of Cl2 gives here the Na plus plus Cl minus. It is a redox reaction. It is a redox reaction. This is because sodium 0 to the plus 1 positive charge increase. It is a positive means removal of electron. It is a oxidation reaction takes place. Here 0 to the minus 1 gaining of electron, reduction, but both oxidation reduction not by any one element. Separate. Nitrogen is oxidation, chlorine is reduction. That's what is a redox reaction. Whereas in this case, Only HNO3, both it undergoes oxidation as well as reduction reaction. That's what is called a disproportionation. Disproportionation reactions takes place. It undergoes generally disproportionate plus 1 into a plus 4 oxidation state maximum, not more than that. Then remaining phosphorus, arsenic, antimony and bismuth also shows variable oxidation state. But formation of variable oxidation state, nitrogen to phosphorus, phosphorus to arsenic, arsenic to antimony and bismuth here plus 5 oxidation state decreases, and here the plus 3 formation oxidation state increases. Here plus 3 oxidation state increases. Means nitrogen shows plus 5 easily, also plus 5, here plus 5. But here too here difficult to show plus 5 oxidation states. So the formation of plus 5 oxidation state decrease, plus 3 increase. Reason is here to show the maximum plus 3 due to inert pair effect. It is very, very important. So what is inert pair effect? Due to the poor shielding or the screening effect. Due to the poor shielding and screening effect, here the rare gas NS2 and NP3, these rare gas inner electrons, nuclear forces directly influences on these valence electrons dragged towards nucleus. That is due to poor shielding or screening effect. Shielding or screening effects, NS electrons do not involve in chemical bonding. Only these electrons are involved. So to show the poor shielding effect, here the 4f and 5d orbitals are main responsible. That is, p and d orbitals are responsible to show the poor shielding effect. So due to the poor shielding effect, here the top to bottom plus 5 oxidation state generally decrease, plus 3 oxidation state formation increase. That's why generally bismuth shows only plus 3, do not show variable oxidation state. Very, very important. Generally nitrogen forms easily, nitride easily, whereas P minus 3 do not form easily, not easily form. Very, very important. Nitride and phosphide, because reason is because of its small size, easily it receives the electrons, and more electronegativity. Due to the more electronegativity in nature, your nitrogen forms easily N minus 3, whereas phosphorus do not forms. So this is the in chemical property variable oxidation states of 15th group elements. Tomorrow I will continue about formation of p pi and p pi bonds and formation of d pi and p pi bonds in chemical properties. Then reactivities of 15th group elements, like reactivity towards hydrogen, oxygen and halogens. Okay, and one more important thing is in p block elements, particularly in inorganic chemistry, that is either in first and second year for objective or theory, better you concentrate, read everyday line to line textbook as a newspaper, memory based concept. Better today only, better you read with this 15th group elements, introduction and synopsis and everything. There is no any big questions in PU or 12th standard. Only 1 mark and 2 marks questions are there. Better you concentrate as objective. Competitive examination pattern only, better you read for PUC also or for 12th standard also. Okay, thank you, take care.